Imagine this huge effort, right, to heal our planet.
Mhm.
One tree, one farm, one community at a
It's a
time.
massive scale.
Yeah. And what would it actually take to track every single step, from the tiniest seedling right up to these vast restored areas across a whole continent?
It sounds almost impossible, doesn't it?
Right.
That's exactly the challenge we're looking at today.
Today, we are doing a deep dive into something pretty remarkable, the Regreening App.
Hmm.
And this isn't like just another app on your phone. It's basically the digital backbone for this monumental land restoration project happening across Africa.
It really is. And
Yeah.
our insights, they're coming straight from the Regreening App user guidelines.
Okay.
Which, sounds dry, maybe,
Right.
but it's surprisingly revealing. It really unpacks the incredible detail and the strategic thought behind collecting this vital environmental data right there on the ground.
Where the work actually happens.
Exactly.
So our mission for this deep dive is to show you how this, seemingly simple app manages really complex data collection, how it empowers local farmers, project managers, and helps reverse land degradation on this unprecedented scale.
And we'll get into the specifics, the surprising details that actually make it work, how a phone app can, quite literally, help regreen a continent.
Okay, let's dive in. So what's the core idea?
So at its heart, the Regreening App is a free, mobile-based Android application. It was developed by World Agroforestry. Its core function, it sounds simple, is to help partners and users gather really precise information on how farmers are actively managing and protecting trees right there on their own farms.
Getting that boots on the ground data?
Precisely.
Yeah.
Capturing that reality digitally.
And it's part of a bigger picture, right? This isn't standalone.
Not at all. It's a key piece of the much larger Regreening Africa project.
Okay.
And that project has a seriously bold target: reversing land degradation across 8 specific African countries. We're talking Ethiopia, Ghana, Kenya, Mali, Niger, Rwanda, Senegal, and Somalia.
Wow, 8 countries. That's
Wow.
huge.
It's a massive undertaking.
So with that kind of scale, I imagine developing the app itself had some really specific goals driving it.
Absolutely. 3 main drivers, really. First, and this is critical for any project this big, is donor reporting.
Ah, the money part.
Well, yeah. It's about turning stories of success into hard, quantifiable, verifiable metrics. Things like households reached, hectares regreened.
The kind of data donors need to see.
Exactly. It's the language that unlocks sustained investment. It's that vital link between the action on the ground and the global funding needed to keep it going.
Okay, so verifiable metrics for donors. Makes sense. What else?
Second was enabling real-time or, near real-time monitoring for the project managers.
So they can see what's happening almost as it happens.
Pretty much. Tracking things like trainings held, nurseries supported, farmer groups engaged. It gives managers an immediate pulse, lets them respond quickly, maybe catch problems early.
Agile management, basically.
You got it. And the third piece?
What was the final driver?
Data integrity. It's all about bridging gaps you might get from older, maybe more fragmented data collection methods.
Right.
It allows for triangulation, comparing different data points to make sure you have a comprehensive, reliable picture of the project's true impact. Consistent, verifiable data you can actually trust.
Donor reporting, real-time monitoring, data integrity.
Yeah.
Got it. So how does this app, this mobile tool, actually manage to capture all that diverse, detailed information? What's the structure?
It's pretty clever, actually. The Regreening app is structured into 4 distinct modules, 4 powerful modules. Each one is designed to capture specific types of data, and together they build that holistic picture needed for the whole initiative.
All right, let's break them down. Module 1.
The first one is the tree planting module.
Makes sense.
This is all about recording land restoration that happens through actual tree planting. So it tracks which households are adopting these practices, where mapping the exact plots where trees are planted, and crucially, the what? The trees themselves. Oh yeah, astonishing detail. We're talking specific species, number planted versus number that actually survived, even down to granular stuff like tree height and circumference.
Wow, not just counting trees, but tracking their individual growth. That sounds key for proving success.
It really is. Then you have the second module, FMNR.
FMNR.
Farmer Managed Natural Regeneration.
Ah, right. Helping existing stuff regrow.
Exactly. So this module records critical info about FMNR plots. It mirrors the tree planting one in many ways: adopted households, hectares, plot mapping, species composition.
Okay.
But its unique value is tracking how farmers encourage that natural regrowth, things like selective pruning of existing shrubs and trees. It often leverages the biodiversity that's already there.
A different approach, but just as important to track. What's Module 3?
Module 3 is the nursery module.
Which makes sense. You need to know where all these seedlings are coming from if you're planting millions of trees.
Precisely.
Yeah.
This module is all about registering and tracking the nurseries. They're the lifeblood, really.
And what data does it capture? Just names and locations?
Oh, much more. Yes, records like name and location, but also species composition, production capacity, even seedling quality.
Seedling quality, interesting.
Yeah, and here's where it gets really insightful for management.
Mm.
It tracks the supply chain. It pinpoints bottlenecks in getting seedlings to farmers.
How so?
It tracks quantities of seeds purchased, seeds sown, how many germinated, how many survived, all the way through.
Wow.
This level of detail lets managers see if the issue is, say, poor seed viability or maybe a distribution problem. It allows for really targeted fixes to boost the whole regreening effort.
That's like a health check for the seedling pipeline itself. Incredible. Okay, and the last one, Module 4.
That's the engagement module.
Engagement, so people stuff.
Exactly. It's designed to keep records of all the project-related human interactions. Think meetings, workshops, training sessions.
Okay.
It documents who attended, where it was held, the topic discussed, and crucially, it connects those topics back to the practices and issues identified on the ground.
So it helps tailor future training.
Precisely. It ensures activities respond to local needs and challenges, and checks if knowledge transfer is actually happening effectively.
So it's not just about what's in the ground, but the human side, the knowledge sharing that makes it all stick. That's really comprehensive.
It aims to be.
But how does this all work in practice, out in the field? What are the realities of using this app in places that might be remote, maybe have poor connectivity?
That's a really important question. And the app is definitely designed with those fieldwork realities in mind. It handles simple text, numbers, images, and of course, location data for trees, plots, nurseries.
Okay, but what if you're miles from anywhere with no cell signal? That must happen all the time.
Absolutely. And that's where its crucial offline functionality comes in. Users can collect all the data without any internet connection.
Vital.
Totally. Data submission only happens later when they find mobile network or Wi-Fi. It's non-negotiable for this to work across large parts of Africa where connectivity can be, patchy at best.
A fundamental design choice, then. Makes sense. What about other practicalities, like keeping the phone charged all day?
Oh yeah, battery life is a big one. The guidelines strongly advise charging phones the night before.
Right.
And carrying a power bank, especially for older phones. They even say don't start a survey if your battery is below 25%.
Wow.
Because GPS drains power so fast. You don't want to be halfway through mapping a plot and have your phone die.
Definitely not. What about storage space? All those photos and data points must add up.
They do. You need about 10 MB free just for the app install, and then they recommend having 50 to 100 MB free for the data and photos you collect.
Okay.
And on photos, they advise selecting an appropriate camera resolution so the files aren't huge, ideally under 6 MB. Larger files just take ages to upload later.
And no filters.
Yeah, the guidelines explicitly say refrain from applying filters or effects. This is about accurate data, not Instagram.
Love it. Keeps it serious. What about physical gear? Is it just the phone?
No. Besides the Android phone itself, minimum Android 4.0.1 with GPS field teams need specific tools.
Like what?
A 1.5-meter measuring stick, mainly for tree height, and a measuring tape, usually 3 to 5 meters long.
For what? Circumference.
Exactly. For measuring circumference, either at breast height for taller trees or around the root collar for smaller ones. These simple tools are key for getting accurate dimension data.
Data that can later be used to check satellite imagery, maybe?
Precisely. Ground truthing.
Okay, so you got your charged phone, power bank, measuring stick, tape measure. You're ready to roll. How do you actually get started with the app itself? Download, registration.
Getting the app is simple enough. It's Android only, remember?
Right. No iPhones for this job.
Not for collecting, no. You can get it via a QR code or find it on the Google Play Store. Designed for wide accessibility.
And once it's installed?
Everyone has to register. Basic details, name, phone, email. Email is mandatory. Country, organization.
Yeah.
Then create a username and password. Standard stuff.
Does it use Google Maps for the mapping parts?
It does, yeah. It uses the Google Maps API.
Okay.
Which means you need location services turned on your phone. The app checks your current location just to activate that API. But, and this is important, it doesn't save the user's personal current location. It's purely for the map functionality within the survey. Good privacy consideration.
Definitely. And for the project teams managing the work, how do they link their specific projects to the app?
Good question. They first have to register their projects on a separate website, the Data Reporting System, or DRS. They use their Regreening App login details for that.
Why the separate step?
Because that process assigns a project data manager role.
Mm-hmm.
That person can then monitor their project's data on the dashboard
Yes.
and assign monitoring roles to other team members. It sets up the data hierarchy.
Creates a clear chain of responsibility.
Got it. And you mentioned typos earlier.
Yeah.
How do they avoid people misspelling project names in the field?
They thought of that. Users download the registered project names directly from the server into the app.
Yeah, avoids errors that could mess up the data analysis later. They also need to periodically update the tree species list in the app to make sure they have the latest additions.
Okay, so setup complete, project names downloaded, species list updated. Now they're ready for offline data collection in the field.
That's right. Wi-Fi, mobile data not needed anymore for collecting the info. Only needed later for the upload.
But GPS needs to stay on.
Absolutely. GPS has to be active during fieldwork. The guidelines recommend setting it to GPS-only mode, if possible, for best accuracy and maybe a better battery life.
Right, let's get into the real nuts and bolts then. Can we walk through an example, say, using the tree planting module? I want to understand the granularity here. How does a user start an entry?
Okay, so you open the module. You can start a new entry or pick an existing one, maybe one you saved as incomplete to finish later, or even review a complete one, though you can't edit finished ones.
Right, so starting new.
First, some basics. It automatically logs the data collector's name. You select the survey date. Then, crucially, you link the entry to a specific project from that downloaded list we talked about.
Or the test options.
Or test or crowdsourcing, if it's not for a registered project, yeah.
And then you profile the farmer or the organization involved?
Correct. You can create a new profile for them, or if they're already in the system, just select their existing profile. That's a huge time saver if you're recording multiple plots for the same farmer.
Makes sense. But before you dive into their plot details, there's that ethical step.
Yes, absolutely critical step first.
Oh.
Consent. The app prompts you to confirm that the interviewee has given their explicit consent to collect the data.
And if they say no?
If consent is declined, the app just returns to the main menu. No data recorded. Respect for the individual comes first.
Good. So assuming consent is given, then what?
Then you get into the details. You record the entity. Are they an individual, an institution, like a school maybe, or a group? And their name.
Okay. Location.
Geographical location next. Select the country, region, or county, district. And if a location isn't listed, users can add new ones.
But spelling matters.
Hugely. The guidelines stress correct, case-sensitive spelling. A typo here can send data for a whole village into the wrong administrative bucket on the back end. Big headache potential.
I can imagine. What about who owns the land? That seems important.
Very significant detail. Users record the plot's ownership type as a private, communal, government, etc. There's an others option too.
And why track that?
It's not just admin. This data helps analyze why regreening takes hold in some places more than others. It connects to land tenure security, maybe institutional support. It often reveals social factors driving ecological success, vital for planning.
Linking land rights to greening success. Powerful. What about the plot itself? Fences, crops.
Yep, they assess if the plot is fenced or enclosed, and what kind: live fence, barbed wire, electric, other. They note if food crops are growing there too, and list which ones.
Like intercropping.
Exactly. They also record the farmer's own estimate of the plot size and the unit they use, like acres or hectares. Helps understand the context.
Okay, now the really cool bit for map lovers. Geotagging the plot. How's that done?
This is where the GPS comes in heavily. Activate GPS, preferably GPS only. Then you walk the boundary.
The boundary of the regreened area.
Yes, the external boundary. And you capture a GPS point at each corner, or each place the boundary changes direction.
And you need good accuracy.
You wait for the GPS accuracy reading on the phone to get down to 6 meters or better, ideally.
But what if it doesn't get that good? Signal issues.
Real world happens. If the accuracy is still over 6 meters after waiting for 2 minutes, the instruction is to save the point anyway. Better to have a slightly less accurate point than no point.
Pragmatic. And the app draws the map as you go.
Yeah, from the third point you drop, it starts drawing a polygon. It updates dynamically with each new point you add along the boundary.
And it calculates the area.
Instantly. Once you close the polygon, it gives you an area estimation right there on the screen.
Great, so the farmer knows exactly how big their plot is.
Here's the critical caution. Users are explicitly told not to share that instant area number with the farmer
Really? Why not?
because it's not an official cadastral survey. Consumer phone GPS has inherent errors. The app's calculation is an estimation.
So it's for project use, not legal boundaries.
Exactly. The objective is to map the plot for project monitoring, calculate its approximate area for reporting, and maybe compare the farmer's perception of the size versus the GPS estimate. Not for settling land disputes.
Vital distinction. Okay, plot mapped. What about the trees within that plot?
Now you get into species details. Users add tree species. They can use the local name.
Which might be the only name the farmer knows.
Right. Local name is mandatory if you don't know the scientific name. Or you can use the scientific name. There's a searchable list, and you can add new ones if needed.
And for each species?
You record the date they were planted, the total number planted, and really importantly, the number still surviving.
Ah, the survival rate.
Yeah.
Key metric.
Absolutely. This data helps understand species suitability, diversity, lets you evaluate management practices, and calculate those crucial mortality rates. It shows what's working and what isn't.
Makes sense. Then you mentioned management and usage.
Yep. Where exactly on the plot are the trees planted? On boundaries, scattered, in blocks. Who planted them? Who manages them?
And what are they doing? Pruning? Watering?
All of that. You select specific management practices being performed, again with another option, and you record the purpose of the trees: fruit, fodder, timber, firewood, soil improvement. What's the farmer's objective?
Helps understand their choices.
Exactly. And assess if the advice they got was effective,
Yeah.
relate practices to species or location, and identify best practices to share.
Okay, and now for what you called the data nuggets, individual tree dimensions. How precise?
Pretty precise. There's a measure tree option. You record a height class like under 1.5 element or over 1.5 element, and then the actual measured height using that stick.
Okay, and circumference.
Yes. For the shorter trees, under 1.5 meters, you measure the RCC root collar circumference right at the base.
Okay.
For taller trees, over 1.5 meters, you measure CD8 circumference at breast height using the tape measure.
Why measure individual trees like that? Seems like a lot of work.
It is, but it's crucial. It lets you assess actual tree growth over time. It provides ground truth data to calibrate and validate remote sensing models like satellite imagery analysis.
Ah, connecting the dots.
Yeah, links ground reality to science and economics.
Fascinating. And you can even GPS tag and photograph individual trees.
Yes, capture the GPS location of specific trees, again aiming for that 6-meter accuracy or better, and take a photo of the whole tree.
What's the goal there?
Training AI. Helps train remote sensing classification models to better identify species intensity from satellite or drone images. Also documents the practices visually and lets you track specific trees over time. It builds this living database.
A living database of restoration.
Wow. Okay, so after all that for one plot, how do you finish the entry?
You can add any relevant comments the farmer made, add more tree species if there were others on the plot you haven't detailed yet, and then you hit finish.
And once it's finished?
It's locked. Cannot be edited.
Yeah.
That maintains data integrity. Done is done.
Right. So that was a deep dive into tree planting. Incredible detail. How do the other modules compare? FMNR, nursery, engagement, are they just as detailed? Do they have unique data points?
They definitely maintain that meticulous level. Lots of overlap in the basics: farmer profile, consent, mapping, dimensions, photos. But each has its own unique focus, too.
Okay, so FMNR, what's its unique angle?
The key specific data point for FMNR, besides all the plot and tree info, is recording the start date of the FMNR practices on that plot.
When did they start managing it for regeneration?
Exactly. That's vital for tracking the timeline and long-term success of that natural regeneration approach. How long does it take? How effective is it compared to planting? Got it. And the nursery module, you said it was like a supply chain check.
It really is. It collects nursery level stuff. Start date, species produced, water source, ownership.
Standard info.
But then it dives deep. Production methods, bare root seedlings or containerized propagation methods, seed grafting, budding. Where did the seeds or grafting material come from?
Source tracking.
Yeah. And then the numbers. Seeds purchased, sown, germinated, survived. Expected seedling age when sold or distributed. Price per seedling.
Wow, that's super detailed.
It allows for this incredibly powerful assessment of market dependence, seed viability, nursery efficiency, everything you need to diagnose and improve that critical seedling pipeline. Actionable insights.
Truly pinpointing where to invest resources. Okay, lastly, engagement module.
This one's about the human interaction.
Yeah.
Who led the meeting or training? Date, venue, topics discussed, type of engagement, key stakeholders present.
Documenting the outreach.
Yes, but again with detail. It meticulously records participation numbers. Total, male, female, youth. Allows for comments, photos.
Why break down participation like that?
To see who's being reached. Are certain groups being missed? Are the topics relevant to everyone? It helps guide future training and ensure community involvement is broad and effective.
Tailoring the human side of the project. Okay, so all this data gets collected tree by tree, nursery by nursery, meeting by meeting, meticulously. What's the final step to make it useful? Getting it off the phone.
That's the upload process. Once records are marked complete, whenever the user gets back into an area with internet Wi-Fi or mobile network, they can upload.
Just hit a button.
Pretty much. The app shows the upload progress. Important not to close the app while it's uploading.
Right, don't interrupt the transmission.
Exactly. Once uploaded successfully, those records are removed from the local list on the phone, which frees up space for the next round of data collection.
And the payoff, where does all that data go and what happens then?
This is where it all comes together. The data lands on the central server, populates the project dashboard, and becomes instantly accessible, at the click of a button, as the guidelines say, for authorized project partners.
So managers across those 8 countries can see what's happening.
Yes, it enables that comprehensive monitoring and, crucially, informed decision-making for the entire huge Regreening Africa project. It turns all that field effort into continent-scale insights.
Wow. What we've just walked through, it's really more than just instructions for an app, isn't it? It feels like a blueprint.
It really is. A blueprint for how precise, ground-level data gathered with smart mobile tech can actually scale up to support massive environmental restoration.
Think about that journey for just one tree you mentioned. Its height, its girth, its exact GPS spot, the soil, the farmer's comments.
All that tiny granular data.
Gathered by people out there with a phone and a measuring stick. It all rolls up. It informs global strategies to fight land degradation, to really change landscapes. It's the micro truly informing the macro.
It is. Which leads to a final thought maybe for you, our listener.
Yeah.
In this age of big data, where we're often overwhelmed by sheer volume, could it be that these meticulous, seemingly small details collected carefully on a mobile phone in a field somewhere are actually among the most powerful tools we have?
Powerful tools for what?
For understanding, for planning, and ultimately for shaping the future of our planet's ecological health. How much power lies in getting the small details right?